Good morning, students. Till now, in gear trains, all the different types of gear trains have been discussed, and in the last class, specifically a epicyclic gear train and how to find the velocity ratio in case of epicyclic gear train. Epicyclic gear train may be simple or a compound epicyclic gear train, and I have listed out the two methods. One is algebraic method, the other one is tabular method. And among these two, to solve any type of problem which is given on either simple or epicyclic gear train, the preferable method to find the velocity ratio is a tabular method, which is the very easiest method. And after discussing the tabular method, we have solved one problem on simple epicyclic gear train. Now, in continuation with the last class, today the second problem, an epicyclic gear train shown in figure. As shown in figure, the number of teeth on wheel A, B and C are 48, 24 and 50 respectively. If the arm rotates at 400 rpm clockwise, find number 1, speed of wheel C when A is fixed. Speed of wheel A when C is fixed. This is the statement of the problem, and the figure is given. It consists of 3 gears, namely A, B, C, and 1 arm. Here, if I list out first given things, he has given the number of T's on the wheels A, B, C. Therefore, on wheel A, 48 T's, therefore TA is equal to 48. On wheel B, 24, therefore TB is equal to 24. On wheel C, the number of T's are 50, therefore TC is equal to 50. Like that, the number of T's are listed out as they are given in the problem. Next, what he says, if the arm rotates at 400 rpm clockwise. Here, all the 3 are being connected to the arm, and this arm is rotating at a speed of 400 rpm. So, speed of arm is equal to 400 rpm, and in what direction? Clockwise. So, students, one should remember, while solving a problem on epicyclic gear train by tabular method, you must keep it in mind. The gears which are rotating in clockwise negative and anti-clockwise as positive according to my sign conventions. So, as I told in the first problem, in order to be sign conventions uniform in the entire class. So, you please remember anti-clockwise is positive and clockwise is negative. Thereby, speed of arm is equal to 400 rpm, and in the bracket write down clockwise. Next, what he is asking to find? Find speed of wheel C, that is NC, is equal to what? If the wheel A is fixed. And the second thing is, speed of wheel A, that is NA, is equal to what? If the wheel C is fixed. Like that, he is asking the two things. So, by reading the statement, I listed out the number of T's and the speed of the arm which is given, in what direction it is rotating also has been written. And he is asking two things. First, find the speed of the wheel C, that is NC is equal to what? If the wheel A of the gear train is fixed. NA, that is speed of the wheel A, is equal to how much? If the wheel C is fixed in a given epicyclic gear train. Now, after listing all this, now draw the table. As I said in the last class, First column is a step. So first column indicates step. Step number 1, 2, 3, 4. Maximum 4 only. Then second column is conditions of motion. And third column is revolutions of elements. Here totally in this problem, there are 4 elements. What are they? One is arm, then the second one is wheel A, third one is wheel B, fourth one is wheel C. Like that there are 4 elements. So revolutions of elements. In that again, depending upon the number of elements, so sub columns will be drawn. So here first one is arm, and later on you have to list the given gears or the wheels in the order, so that I can able to find out the velocity ratio or the speed of the elements properly. Now here first column is step, second one is conditions of motion, and third one is revolutions of elements. After writing this, first preferably I told arm is to be fixed. In any given epicyclic gate train, if there is an arm, you try to see that arm is assumed to be fixed always. Therefore, first element in the revolutions of elements column is arm. Then second is, after assuming the arm to be fixed always, second element to be entered into the table is which gear or which wheel. Here I would like to rotate the gear A first in anti-clockwise direction. Therefore, wheel A should be written next after the arm. And next, wheel A is in contact with which wheel? B. Therefore, next is wheel B. Next, wheel B is in contact with wheel C, so that I can find the velocity ratio. Therefore, wheel C. Like that in the order. First, the element is by default in most of the epicyclic gate trains arm, because that is the one which we assume that to be fixed. After fixing, second point is for which wheel you would like to rotate. That is to be entered. Here I would like to rotate the wheel A. Therefore, wheel A I rotate. After that, wheel A is in contact with which wheel? So wheel B. Therefore, wheel B. Wheel B next in contact with wheel C. Like that in the order is should to be entered into the table. Now, what is the first step? Arm is fixed and wheel A, I will rotate it +1 revolutions. Means by fixing the arm, I will rotate the wheel A +1 revolution. Means +1 according to our sign conventions. Plus means anti-clockwise. By how many revolutions? 1. So rotate the gear A or wheel A in anti-clockwise direction. How? By fixing the arm. Arm is fixed and wheel A given +1 revolutions. So if I rotate the gear A in anti-clockwise direction, that information what I am going to find now should be entered in the first table. So arm is fixed and wheel A given +1 revolutions, or wheel A is rotated 1 RPM, 1 revolution in anti-clockwise. Arm is fixed, therefore speed of the arm is 0. And next, what is the speed of wheel A? So it has been rotated in anti-clockwise, 1 revolution, therefore +1. Once the wheel A is rotated by +1 revolutions, the wheel B will rotate in opposite direction, because wheel A and B are having the teeth or having external teeth. Therefore, wheel B will rotate in clockwise direction. Therefore, what is the speed of wheel B? Speed of wheel B, how I should get? Remember the velocity ratio formula. So velocity ratio in between A and B, because A and B, that is equal to NA by NB is equal to TB by TA, or NB by NA is equal to TA by TB. Now I want the speed of wheel B. which is equal to reciprocal of ratio of reciprocal of their teeths. I am finding the speed of wheel B. Therefore, TA by TB, previous by current wheel. So TA by TB. And it is rotating in clockwise, therefore negative, according to our sign convention. Like that, I can find the speed of wheel B. How I can find the speed of wheel B? You rotated wheel A in anti-clockwise and wheel B is rotating in opposite direction because both wheels are having external teeth. Now what is the velocity ratio in between A and B? According to the formula, NA by NB is equal to TB by TA, or OR NB by NA is equal to TA by TB. Now NA is equal to 1, therefore NB by 1 is NB. NB is equal to TA by TB, or simply remember blindly, I want speed of wheel B. So previous wheel is A and current wheel is B. So TA by TB. You can write it, and it is rotating in clockwise according to our sign convention minus. Next, speed of wheel C. Speed of wheel C. So how to find the wheel C? So that is, because wheel C is not directly in contact with A. So how to find it? TA by TB, which is the velocity ratio in between A and B, into TB by TC. So TB gets cancelled, then TA by TC. So TA by TC. But wheel C and B, which are meshing with each other, are also having external teeth. Therefore, C will be rotating in anti-clockwise direction. Therefore, plus TA by TC. Or blindly, I want the speed of wheel C with respect to always the reference one or the first one. So that is TA by TC. Previous divided by current. So previous means first one. So TA by TC, and it is rotating in anti-clockwise, therefore TA by TC. Like that I can find the speed of all the elements by fixing the arm and rotating the wheel A in anti-clockwise direction by one revolution. Next, go to the next second step. Arm is fixed. Now let us give wheel A plus X revolution. Now what I did in the first step, I rotated wheel A in by one revolution anti-clockwise. Now instead of that, let us rotate the wheel A by plus X revolution. Nothing but, in other words, what I should do, all the first row values should be multiplied with plus X. 0 into X is 0. 1 into X is plus X, minus TA by TB into X is nothing but minus X into TA by TB, and X into TA by TC is X into TA by TC. Like that, all these first row values should be multiplied with X plus X. 0 into X is 0, 1 into X is plus X, minus TA by TB into X is minus X TA by TB, TA by TC into X, what I should multiply, then it will be X into TA by TB. Like that, in the second step, I should multiply all the values with plus X. Next, go to the third step. In the third step, I should add plus Y revolutions to all the elements. So, plus Y, plus Y, plus Y, plus Y. Next, find out in the fourth step, total motion. Total motion, nothing but I should add second step and third step of each element. Now if I take arm, what is the second step value? 0. And what is the third step value? Plus Y. If I add 0 plus Y, I am going to get plus Y. What is this plus Y indicates? It is the speed of the arm in the table. Next, go to the wheel A. Second one is X. Third step is plus y. If I add these two, x plus y, that is indicating the speed of the wheel A. Similarly, if I add second and third of the wheel B, I will get plus y minus x into TA by TB. If I add the fourth element, second and third step, then I will get y plus x into TA by TC. Like that, I can find the total motion. In the last row, under the column arm, this indicates, that is plus y indicates speed of the arm, x plus y indicates speed of the wheel A, y minus x into TA by TB is speed of wheel B, y plus x into TA by TC is what? It is the speed of the wheel C in the table which we have prepared. Now like this, the table is to be completed, then go to the findings. Now first thing, what I should find? I should find the speed of wheel C if the wheel A is fixed. So NC is equal to what? If wheel A is fixed. So wheel A I am fixing, nothing but speed of the wheel A is 0. So therefore NA is equal to 0. According to the condition what is asking. So I should find the wheel speed of wheel C by fixing the wheel A. Therefore NA is equal to 0. But from the table, what is the speed of wheel A? That just now I told, it is x plus y. Therefore x plus y is equal to what? It is 0. Because x plus y indicates what? It is the speed of wheel A, that is equal to 0 because wheel A is fixed. Next, speed of the arm, that is equal to 400 rpm clockwise, means minus 400 rpm. But from the table, what is the speed of arm? It is plus y. Therefore, y is equal to minus 400. Like that, you must note down. Now, what I should find? I should find NC is equal to what? Now, to find this, I know y is equal to minus 400 rpm. You substitute this y is equal to minus 400 in equation 1. Thereby, I will get x plus y is equal to 0. Y is what? Minus 400. So x minus 400 is equal to 0. Then x is equal to 400. Why I am doing this? Because I want to find the speed of wheel C. But what is the speed of wheel C from the table? It is y plus x into TA by TC. Here I know y value, that is minus 400, TA is 48 and TC is 50. But I don't know the value of x. So first I should get ready with the value of x. Then only I can substitute all values, that is x, y value, TA, TC, so that I can get the speed of wheel C. Therefore, in the first bit, I repeat once again, I should find the speed of wheel C if the wheel A is fixed. So wheel A is fixed means NA is equal to 0, but from the table, what is NA value? It is x plus y. Therefore, x plus y is equal to 0. Then speed of the given arm is 400 rpm clockwise. According to our sign convention, speed of the arm is equal to minus 400. But from the table, speed of the arm is plus y. Therefore, plus y is equal to minus 400. Now, you call it x plus y is equal to 0 as equation 1 and you know the value of y. Therefore, minus 400. Substitute in it to get the value of x. Now, from the table, note down what is the speed of wheel C. That is NC is equal to, from the table, y plus x into TA by TC. Now you know the value of y, that is minus 400, and plus x. X just now we found, it is plus 400 into TA is the number of teeth on the wheel A, that is given as 48, and TC is the number of teeth on the wheel C, which is given as 50. Now if I substitute, then I am going to get minus 16 rpm. So therefore, speed of wheel C, that is NC is equal to 16 rpm, and in the bracket you must write clockwise because it is minus, like that. Then take the second one. What is the second thing to be calculated? Speed of wheel A is equal to how much if the wheel C is fixed. So NA is equal to what if the wheel C is fixed? So wheel C is fixed means NC is equal to 0. But from the table, NC is equal to y plus x into TA by TC. Therefore, y plus tx into TA by TC is equal to NC. What is NC? 0. Why 0? Because wheel C is fixed. Now y is equal to minus 400 plus x we don't know into 48 by 50. Now if I simplify, I am going to get the value of x. Like that. So based on the given condition, wheel C is fixed. From the table, note down what is the speed of wheel C, that is y plus x into TA by TC. And y value, it is given directly in the statement, that is minus 400 plus x. X is not equal to 400. One should remember. Because that value we don't know according to this condition in the second thing which we have to calculate. Therefore, x as it is into TA is 48, TC is 50. If I substitute and simplify, x is equal to 416.67. Now, what I should find? Speed of wheel A, that is NA. From the table, what is the speed of wheel A? X plus y. Why it is already given in the problem, minus 400. Just now we got the value of x. How I got the value of x? Because wheel C is fixed, he is telling. So from the table I took the value of speed of wheel C and equated it to 0 because it is fixed. Then thereby I got the value of x. Now I got the value of x and y is already given in the statement of the problem. If I substitute both the values, I will get 16.67 RPM. Means it is plus 16.67 RPM. Therefore, speed of wheel A, that is NA, is equal to 16.67 RPM, and in the bracket you must write anti-clockwise because it is plus. Similarly, now take the third problem. In a reverted epicyclic gear train, the arm A carries gears B and C and a compound gear D and E. The gear B meshes with gear E and the gear C meshes with the gear D. And number of teeth on gears B, C and D are 75, 30 and 90 respectively. Then find the speed and direction of gear C when gear B is fixed and the arm A makes 100 RPM clockwise. Now this is the figure. It is called as epicyclic gear train because there is one compound gear D and E, both are yes. So first and the last gear are rotating in same direction. Therefore, so it is reverted epicyclic gear train. Totally, one is compound gear DE, second one is gear B, third one is gear C, and there is one arm, that is arm A. Now read the statement and note down the given things. So it is a reverted epicyclic gear train. Number of teeth on the gears B, C and D are given. Therefore, TB is equal to 75, TC is equal to 30 and TD is equal to 90. And he is asking find the speed and direction of gear C. Means NC is equal to what? What is the speed of the gear C? That is NC is equal to how much? And direction, whether it is rotating in anti-clockwise or clockwise. When gear B is fixed, means NB is equal to 0. So I should find NC is equal to how much if NB is equal to 0. First of all, here I have totally 4 gears. One is gear B, gear C, gear D and gear E. But gear D and E mounted on the same shaft where it is said to be compound gear. So therefore, out of these 4, I know only number of T's on the gear B, gear C and gear D. Gear E is don't know. So first let us find how many number of T's on the gear E, which is meshing with the gear B. So from the geometry of the figure, go back to your reverted gear train. Now from the geometry of the figure, I can write diameter, pitch circle diameter of gear B plus pitch circle diameter of gear E. So sum of dB plus dE, because dB, dE are in mesh with each other. So from the geometry of the given reverted epicyclic gear train, we can write pitch circle diameter of gear B, that is dB, plus pitch circle diameter of gear E, that is dE. So dB plus dE is equal to, I can write sum of the pitch circle diameters of gear C and gear D, that is DC plus DD. After writing from the geometry, one should assume the moduli is same for all the gears. So when we assume the moduli of all the gears are same, then the pitch circle diameters are directly proportional to the number of T's. So hence, instead of diameter, now I can, because pitch circle diameter D is directly proportional to number of teeth. When the moduli of all the gears is same. Therefore, now the above equation, that is dB plus dE, is nothing but TB plus TE, because D is directly proportional to T. So is equal to TC plus TD. Now here TB is known, that is 75, TE that we don't know. So as it is, I am writing TE, that is equal to TC plus TD, 30 plus 90. Now if I simplify, number of T's on the gear E is equal to 120 minus 75, that is equal to 45. So that now I am ready with the number of T's on all the gears, B, C, D and E. Now prepare the table. Step, first column, second, conditions of motion, third, revolutions of element. Now in the revolutions of element, now first one, as the given gear train is having a arm, I will assume the arm I am going to fix. Therefore first one is arm A. Next, I will give a rotation to the compound gear. Therefore gear DE. When I rotate the compound gear DE, then next B will rotate, therefore gear B. When I rotate gear B, then the gear C will rotate, therefore last one is gear C. Like that, in the order, I am just listing the number of elements under revolutions of elements. So arm A is first because it is going to be fixed. Next, I am giving a rotation for the compound gear DE. Therefore, second one is gear DE. Next, as once I rotate compound gear, B will rotate. Therefore, gear B is next. Then, after that, finally gear C. First step, arm is fixed and give compound gear plus 1 revolution. Means you have to rotate the compound gear in anti-clockwise by how many revolutions? 1 revolution. Thereby arm A is fixed. Therefore in the arm A cell I should put 0. Next, in the cell gear DE I should write plus 1 because gear DE, that is a compound gear, is rotated in anti-clockwise direction by 1 revolution. Therefore plus 1. Next, gear B, speed of gear B. Now look at, you are rotating compound gear in anti-clockwise. Next, gear B is in contact with E. So therefore, E and B, which are meshing with each other, are having external teeth. Therefore, gear B will rotate in opposite direction. So gear E is rotating in anti-clockwise. Therefore, gear B is rotating in clockwise. Therefore, minus into what is the speed of gear E? So now EB, that is nothing but I am finding the speed of wheel B. I want the speed B speed. So gear B speed. So B is rotating or driven with the help of gear E. Therefore, TE by TB, that is the speed of the gear B, and it is rotating in clockwise, therefore minus. Next, once the gear B rotates in clockwise, gear C will also rotate because both are mounted on the same shaft. So in the same direction they will rotate minus, but the speed is gear C is in contact or meshing with gear D. Therefore, TD by TC will be the speed of the gear C. So previous and present. So like that one can find the speed in the first step of all the elements. Arm is fixed, therefore 0, and you are rotating compound gear DE by 1 revolution in anti-clockwise, therefore plus 1, and gear B is in mesh with gear E, so directly, so E is driving the gear B, therefore B is driven and E is driver. So hence TE by TB will give the speed of the gear B, and it rotates in clockwise, therefore minus I have put. Next, gear C speed. So gear C is in mesh with gear D, therefore TD by TC is the speed of gear C, and C is also rotating in the same direction of the gear B, that is clockwise, hence this is also negative. So next, second step, arm A is fixed. Now compound gear DE is to be given plus X revolution. It means I should multiply all the values of first row with plus X. Multiply 0 into X is 0, 1 into X is X, X into minus TA by TB minus X TE by TB, X into minus TD by TC minus X into TD by TC. Next, third step, add plus Y to all the elements, that is plus Y, plus Y, plus Y, plus Y. Next, fourth step, total motion. So in the total motion, I should find the second step and third step value of each element. So 0 plus Y is Y, X plus Y is X plus Y, minus X into TE by TB plus Y, that is nothing but Y minus X into TA by TB. Then minus X into TD by TC plus Y, that is Y minus X into TD by TC. Simply I should add 2 and 3 to get 4. 0 plus Y is Y, X plus Y is X plus Y, like that. Y minus X into TA by TB, Y minus X into TD by TC. Like that I should find the total motion of all the elements. Now in the last row, Y indicates speed of the arm A, X plus Y is the speed of compound gear DE, Y minus X into TE by TB is the speed of the gear B, Y minus X into TD by TC is the speed of the gear C. Like that the table is to be completed. Now find out what is to be found in the given problem. Speed and direction of gear C when gear A is fixed. Therefore, gear B is fixed. From the table, what is the speed of gear B? It is Y minus X into TE by TB. So Y minus X into TE by TB is equal to 0. Now, what is the Y value? It is given because he is saying gear B is fixed and arm A makes 100 revolutions per minute clockwise. So arm A means from the table arm A is Y. Speed of arm A is Y. So therefore Y is equal to 100 RPM, and it is minus because clockwise. Now substitute this Y value in the above equation. Then it is Y is minus 100 minus X is unknown into TE is the number of T's on the wheel E, that is 45, and number of T's on the wheel B is 75. If I substitute and simplify, I will get the value of X. Y is minus 400. If I substitute in equation 1, only unknown is X. That I got it as minus 166.67. Now what is to be calculated? Speed of gear C, NC. From the table, what is the speed of gear C? It is y minus x into TD by TC. Now y minus 100 minus x is also minus 166.67 into TD is 90 and TC is 30. If I substitute, I am going to get plus 400 RPM. What is this? It is speed of gear C, that is NC is equal to 400 RPM, and in the bracket I will write it anti-clockwise because the direction is anti-clockwise. Why anti-clockwise? According to our sign convention, I wrote it as anti-clockwise because it is plus. Right. Next one, that is problem number 4. Figure shows an epicyclic gear train. Wheel E is fixed and wheels C and D are integrally cast and mounted on the same pin. If the arm A makes 1 revolutions per second counterclockwise, means anti-clockwise, determine the speed and direction of rotation of the wheels B and F. So I should find the speed and direction of wheels B and F. And this is the figure. Now from the figure one can note down the number of T's. It is an epicyclic gear train. So TB is 20, TC is 35, TD is 15, TE is 20, TF is 30. These are all the values of the number of T's on all the wheels or gears. And if the arm A makes 1 revolutions per second, that is NA, arm means it is here, he is telling in the figure arm A. Arm A makes 1 revolutions per second, that is NA is equal to 1 RPS, not RPM, RPS. And counterclockwise means anti-clockwise, therefore plus 1 RPS. Plus 1 RPS is nothing but plus 60 RPM. And I should find the speed and direction of wheel B, that is NB is equal to what? And wheel F, that is NF is equal to what? Now prepare the table. First one, step 1, conditions of motion. Now look at step, first column is step, second column is conditions of motion, and in the third column, that is revolutions of elements. Here there is R, therefore first one is arm A, that is by default, because I am going to fix the arm A. Next, give the rotation for the wheel B, therefore wheel B is the next, so gear B I wrote it second. Next, gear B is in contact with the compound gear CD, therefore gear CD. Then compound gear is in contact with gear E, therefore gear E next. Then after that gear F. Like that here, first fixed one, second element is the one for which I am going to give a rotation. Here I am fixing the arm A, therefore arm A is first. Second, I am going to give the arm B, I am going to rotate the wheel B, therefore gear B is second. Later on, which one is in contact with which one? Like that you can note it down in the order so that you can able to calculate the speed of each and every element by using the velocity ratio formula. Now the first step, arm A is fixed and gear B is to be given plus 1 revolution, means gear B is to be rotated in anti-clockwise by how many revolutions? 1 revolution. Therefore arm A, in the arm A cell, I am going to put 0. Why? Because arm A is fixed. Then gear B, in this cell I am going to write plus 1 because gear B is rotated by 1 revolution, therefore 1, and it is plus because according to our sign convention anti-clockwise is plus 1. Next, gear CD. What is the speed of gear? Compound gear CD. So here in the compound gear CD, the D gear, the B is driving the gear D. Therefore, dB by dd, TD. So ratio of the number of T's on the wheel B, that is TB by TD. That gives the speed of the compound gear, and because here B and D are having external T's, so compound gear will rotate in opposite direction, in a direction opposite to the direction of wheel B. Wheel B is rotated in anti-clockwise. Therefore, the compound gear CD, which is in mesh with gear B, will rotate in opposite, means clockwise. Therefore, I put negative. So minus TB by TD. So I want next. So next, the compound gear is driving the gear E. So therefore, speed of gear E. How to find the speed of gear E? So that is TB by TD, then into TC by TE. So together will give you the speed of gear E. Next, after that, gear F. So that is minus. So here compound gear is driving the gear E in opposite direction. Therefore, this is plus only. The speed of gear E is nothing but, right, TB by TD into TC by TE. Next, gear F is in mesh with gear E. So therefore, with respect to the previous one always, so it is TB by TD into TC by TF. And it is rotating in clockwise, therefore minus. Like that, the first you must find arm, it is fixed 0, gear B rotated by 1 revolution in anti-clockwise, therefore plus 1. Gear CD is rotating in clockwise, therefore minus TB by TD. Next, gear E is rotating in anti-clockwise, therefore plus only. What is, how to find its gear ratio? TB by TD into TE by TC, TC by TE, like that. So next, gear F is rotating in clockwise, therefore minus. And how to find its ratio? TB by TD with respect to the first one, TB by TD into TC by TF. So next, second step, arm is fixed. So now the gear B should be given plus X revolution. Nothing but I should multiply all the values with X. 0 into X is 0, plus 1 into X is X. Then minus TB by TD into X is minus X into TB by TD. Then X into TB TC by TD TE. Then minus X into TB TC by TD TF. Next, in the third step, add plus Y revolutions to all the elements. That is plus Y, plus Y, plus Y, plus Y, plus Y. How many elements are there? For all of them, you have to add plus Y, plus Y, plus Y, and so on. Then find in the fourth step total motion. So where I should add second and third value. 0 plus Y is Y. Second and third of each element. Arm A element, second step value is 0, third step value is Y. So 0 plus Y is Y. Then X plus Y is X plus Y. Minus X into TA by TD plus Y is Y minus X into TB by TD. Then Y plus X into TB TC by TD TE and Y minus X into TB TC by TD TF. So all the values in the fourth row indicates or represents speed of the arm. A is Y, speed of gear B is X plus Y, Y minus X into TB by TD is gear CD speed, and Y plus X into TB TC by TD TE is the speed of gear E. Like that, all the values in the fourth row indicates the speed of each and every element to be taken in order to find the things what he is asking in the problem. Now, as I said, I should find if the RA makes 1 revolutions per second counterclockwise, means anti-clockwise, determine the speed of wheels B and F. Therefore, from the table, first of all, speed of the arm, that is NA, is equal to what? It is Y. And that Y, which is equal to plus 1 revolutions per second, that is nothing but plus 60 RPM. Next, determine wheel E is fixed. In the statement you can see wheel E is fixed, that is NE is equal to 0. From the table, speed of the gear E is equal to Y plus X into TBTC by TDTE, that is equal to 0 because wheel B is fixed. Therefore, now substitute Y value, which is given as plus 60, plus X into, substitute the given known values of the number of T's, 20 into 35 by 15 into 20. So if I simplify, I am going to get X is equal to minus 25.6. X value is minus 25.6 and Y value is equal to plus 60. So therefore, now the speed of the gear B, that is NB, what I should calculate from the table, the speed of the gear B is equal to X plus Y. X is minus 25.6 and Y is plus 60. Therefore, if I simplify, I will get 34.4, means plus 34.4 RPM. So, NB is equal to 34.4 RPM and in the bracket anti-clockwise. Next, I should find the speed of another wheel. What is that wheel? Wheel F. So, speed of the gear F or wheel F from the table, it is equal to Y minus X into TBTC by TDTF. So, Y value, so once again it is plus 60 and X value is minus 25.6. Now substitute and simplify. I am going to get 99.82 RPM. It is plus, it indicates the wheel F is rotating in anti-clockwise. So similarly, next one, an epicyclic gear train. Problem number 5. An epicyclic gear train consists of 3 gears A, B and C as shown in figure. The number of T's on the annular gear A. So I said in the discussion, while discussing about the epicyclic gear train, what is meant by annular gear train? If any gear is having internal T's, then it is said to be an annular gear. So number of T's on annular gear A is 74 and on gear C is 34. The gear B meshes with both gears A and C and it is carried an arm D which rotates about the center A at 25 RPM. If the gear A is fixed, then find the speed of gear B and C. So now look at, this is the figure. Now here there are 3 gears. One is gear A, gear B, gear C. Gear A is having internal T's, therefore it is said to be annular gear A, and gear B and gear C both are having external T's, and in addition to the 3 gears, the other one is arm D. Now if I read the problem, here the given things, if I list out, number of T's on the gear A is 74. So TA is 74 and number of T's on the gear C is 34. So TA and TC are 74 and 34. Then the gear B meshes, gear B is meshing with both gear A and gear C, and this is carrying an arm D. So arm D, gear B is carrying arm D which rotates about the center A, about the center of the gear A at 25 RPM. Therefore, speed of the arm D, that is ND, is equal to 25 RPM. Then if the gear A is fixed, means If NA is equal to 0, then find the speed of gears B and C, that is NB and NC is equal to how much. Now, so prepare the table. First is step, second one is conditions of motion, third one is revolutions of elements. In the revolutions of element, as there is a arm, so let us fix the arm D and give the rotation for the gear C. Therefore, first one is arm D, next is gear C. After gear C, I should write gear B because gear C is in contact with gear B. So, next after gear B, I should write gear A. Like that, I can list these elements in the order. First, the element which I am going to assume it as fixed. Second, for which gear or which wheel I am giving a rotation. After that, next I should list out the other elements in such a way that I should be able to find the speed. So now the first one, let us fix the arm D. So arm D is fixed and rotate the gear C by +1 revolution. Therefore, arm D is 0 because fixed. Gear C is rotated by +1 revolution. Now what is the speed of the gear B? So gear B speed, how to find the gear B? C is in directly mesh with the gear B. Therefore, TC by TB, that gives the speed of the gear B, and it rotates in clockwise because you are rotating gear C in anti-clockwise and gear B will rotate in clockwise. Why? Because C and B, which are in mesh with each other, are having externalities. Therefore, it rotates in opposite. Opposite means clockwise. So, hence minus TC by TB. Next, once the rotate gear B in clockwise, this rotates the gear A. In what direction? In the same direction, means in clockwise, because gear B and gear A is having internalities. So gear B is in mesh with the internalities of a gear A. Therefore, gear B, in what direction it is rotating? In the same direction gear A is rotating. So gear A is first TC by TB previous into TB by TA. So TB gets cancelled. So TC by TA is the speed of the gear A, and it is also rotating clockwise because of internalities. So therefore minus. Next, step 2, fix the arm D. Arm D is fixed anyhow, and gear C, instead of +1, now let us rotate it by +x revolution. Nothing but I should multiply all these first row values with +x. 0 into +x is 0, +1 into x is +x, then minus TC by TB into x is minus x into TC by TB, and minus TC by TA into x is nothing but minus x into TC by TA. Like that, multiply with all values with x. Next, add +y revolutions to all elements. +y, 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 +y. Next, find in the fourth step total motion. 0 + y is y, x + y is x + y minus x into TC by TB, y minus x into TC by TA. Like that, table is to be completed. So, after completing the table, now number of teeth on all the gears should be known. Here totally, other than the arm D, how many gears are there? 3 gears are there. Gear A, gear B, gear C. But out of these 3 gears, so number of teeth on which gears are known? Gear A is known, gear C is known, but gear B is unknown. So therefore, I should get ready with the number of teeth on the gear C. So how I can write it? Now look at the figure. Now look at the figure. From the geometry of the figure, I can write the diameter of the wheel A, that is dA, is equal to diameter of the wheel C plus the 2 times of the diameter D. So therefore dA is equal to DC plus 2 times the diameter B. Then that gives the diameter of the wheel A. So therefore, dA is equal to pitch circle diameter of gear A, which is the bigger one, outer circle. dA is equal to, at the center there is a DC. So gear C. So diameter of the gear C, and in between gear A and gear C there is a diameter, there is a wheel B. Therefore its diameter. Like that on the other side, if I fill one more, then that will give you the diameter of the gear A. Therefore dA is equal to DC plus 2 times. One side it is there in the figure. If I take it on the other side same size, then it will be equal to the diameter of gear A. So therefore 2 times the diameter of B. So dA is equal to DC plus 2 dB. But since the moduli for all the gears is to be assumed as same, then the pitch circle diameter is directly proportional to the number of days. Therefore, TA is equal to TC plus 2 TB. TA is given 74, TC is 34. Only unknown is TB. That you substitute and simplify, whereby you are going to get TB is equal to 20. Let us get ready with the number of days. Now find out what he is asking in the problem. Gear B and C. Speed of gears B and C if gear A is fixed. Gear A is fixed means NA is equal to 0. From the table, what is the speed of gear A? Y minus X into TC by TA. So Y minus X into TC by TA is the speed from the table, that is equal to 0. Now Y, what is Y? Y is the speed of the R. Y is the speed of the R from the table. Y is equal to 25 RPM. Now look at, he has not given in the statement of the problem whether 25 RPM is clockwise or anti-clockwise. If nothing is given, you must assume anti-clockwise. So it is plus only. So Y is equal to plus 25 RPM. So now substitute Y value 25 minus X, which is unknown, into TC is 34, TA is 75. So if I simplify, I am going to get the value of X is equal to 55.5. Now first find the speed of gear B, that is NB. From the table, speed of the gear B is minus Y minus X into TC by TB. Y is 25, it is plus 25, and X is plus 55.5. So 25 minus X 55.5 into 30, 34 by 20. If I substitute, I am going to get minus 69.35 RPM. What it indicates? Speed of the gear B, that is NB, is equal to 69.35 RPM, and minus whatever we got, it indicates it is rotating in clockwise direction according to our sign convention. Therefore, in the bracket, write down clockwise. Next, speed of the gear C, that is NC. From the table, speed of the gear C is, from the last row, X plus Y. So NC is equal to X plus Y. X is 55.5, Y is 25. If I add both, 80.5 RPM. Therefore, NC is equal to 80.5 RPM. In the bracket, you write down as anti-clockwise because it is plus 80.5 RPM. RPM. Similarly, now take the next one. The figure shows an epicyclic gear train in which arm A is fixed to the shaft S, which you can see as a simple like a point because it is being inserted, it is being mounted perpendicular to the gears. So that is why here you can see in this view, front view, so as a point. which I wrote it as S. The wheel B having 100 teeth rotates freely on this shaft S. Wheel F 150 teeth is separately driven. If the arm A runs at 200 rpm, wheel F at 100 rpm in the same direction, find the number of teeth of gear C, and second, speed of the wheel B. So now look at here. So it is a epicyclic gear train having arm A. Next, there are three wheels: wheel F, wheel C, and wheel B. Now, given things, if I list out here, number of T's on the wheel B, that is TB, is equal to 100, and wheel F is having 150 teeth. So TB is equal to 100, TF is equal to 150. Next, if the arm A runs at 200 rpm, so speed of the arm A is 200 rpm. So here he is not mentioning means anti-clockwise, plus means anti-clockwise, and the speed of wheel F 100 rpm, that is plus. So both are in the same direction. Then find the number of teeth of gear C, that is TC is equal to what, and speed of the gear B or wheel B, NB is equal to what. Now let us find the number of teeth on the wheel C, that is TC. Now if I look at the diagram, so diameter, pitch circle diameter of gear F, that is DF, is equal to DB, diameter of the gear B, plus diameter of the gear C and diameter of the gear C. So here there are two wheels on either side of the wheel B which are of same diameter. So therefore DF, that is pitch circle diameter of this wheel F, is equal to diameter of the wheel B plus 2 times the diameter of DC, because DC plus DC, 2DC. Now as the moduli of each gear is same, therefore the pitch circle diameter is directly proportional to the number of T's. Therefore this can be written as DF means TF is equal to TB plus 2TC. So D, instead of D you write it as T. Then TF is equal to TB plus 2TC. TF is known 150 and TB is also known 100. Only unknown is TC. So if I substitute and simplify, we get number of T's on the gear C is equal to 25. Like that, first one I got it. Next, to find the speed of wheel B, let us draw the table. So first step, second, conditions of motion, third one, revolutions of elements. Now look at, as there is an arm, let us fix the arm. Therefore, first one in the revolutions of elements is arm A. And next, let us rotate the gear B in anti-clockwise by 1 revolution. Therefore, gear B is next. After gear B is in contact with gear C, therefore gear C. Then gear C is in contact with F, therefore gear F. Like that in the order. First one is R, because I am going to fix the R. So first one is R. Second, I am giving a revolution to the gear B, therefore second is gear B. Third, gear B is driving the gear C, therefore gear C. And gear C is driving the gear F, therefore gear F. Like that, you just draw the elements. Then step number 1, arm A is fixed and gear B should be given plus 1 revolution. Plus means you indicate you are rotating the gear B in anti-clockwise. So arm A is fixed, therefore 0 first. Next, gear B is rotated, plus 1 revolution, hence enter plus 1. Then gear B is in mesh with gear C and externally, means gears B and C are having in contact with external teeth. Therefore, gear C will rotate in opposite direction. So what is the speed of the gear C? It is TB by TC. And it is rotating in opposite, means clockwise. According to our sign convention, clockwise is negative. Therefore, minus TB by TC is the speed of the gear C. Next, once you rotate gear C, the gear C will drive the gear F. Therefore, so how to find the gear F? TB by TC, that is previous one, into TC by TF. So TB by TC into TC by TF. So TC gets cancelled. Then TB by TF is the speed of the gear F. Minus means because gear C is in contact with gear F internally, because gear F is having internalities. So therefore, in what direction gear C is rotating, in the same direction F will rotate. So gear C is rotating in clockwise, therefore F is also rotating in clockwise, therefore minus. Like that, the first information to be entered in the first row. Next, second step, arm A is fixed, right? Still, gear B, instead of plus 1 revolution, now it should be given, it should be rotated by plus X revolution. Nothing but simply I have to multiply all the values of the first row with plus X. I have to multiply with plus X. 0 into plus X is 0. Plus 1 into X is plus X. X into minus TB by TC is minus X into TB by TC. Minus TB by TF into X means minus X into TB by TF. Next, third step, add plus Y revolutions to all elements. Plus Y, plus Y, plus Y, plus Y. Now find in the fourth step total motion. I should multiply second and third step values of each element to get fourth one. So 0 plus Y is Y. X plus Y is X plus Y. This plus this means Y minus X into TB by TC, Y minus X into TB by TF. Like that, I should complete the table. After table, among the two things which I should find, number of T's on the gear C is already found, that I got it as 25. Now I should find the speed of wheel B. Speed of wheel B. If the speed of arm A is 200 rpm and wheel F speed is 100 rpm in the same direction. Now from the table, what is the speed of arm A? That is, from the table it is Y. You have to look at last row only always once the table is completed. So Y is equal to the speed of the arm. Therefore, speed of the arm A, that is NA, from the table is equal to Y, which is equal to plus 200 rpm. And similarly, wheel F speed is also given as 100 rpm. But what is the speed of wheel F from the table? Y minus X into TB by TF, that is equal to plus 100. Now Y is known, plus 200 you substitute, minus X which is unknown into TB is 100, TF is 150. So that is equal to 100. If I substitute and simplify, only unknown is X, that X is equal to 149.25. So how much is the Y value? 200, and X is equal to 149.25. After finding X and Y, now speed of wheel B, which is to be calculated, should be taken from the table. So what is the speed of gear B from the table? It is X plus Y. Therefore, NB is equal to X plus Y. And X, 149.25, which is plus Y, that is 200, which is also plus. If I add both, I am going to get the speed of wheel B, that is 349.25 rpm, as it is plus. So in the bracket you write down anti-clockwise. So like that, this problem, speed of the wheel B can be calculated.